Good evening, everyone. Welcome, all of you. Very, very good evening. All right, everyone can hear me properly. Please once confirm. We are going to start our discussion on radicals and carbenes. Basically, practice questions, latest CSR net question on radical and carbene topic. Very good evening, Prasad. Ganesh, welcome. Disha, Sudeep, Shubhadeep, welcome all of you. All right, very, very good evening once again. So, guys, I had discontinued these live sessions for a few days. I was not well, I had fever, and we are going to continue from today onwards. Okay, so yes, everyone, once again, we start the discussion. अच्छा, क्योंकि ये बहुत ही इजी सा टॉपिक है, अभी हमने रिएक्शन मैकेनिज्म कर लिया है, ठीक है, अभी मूव ऑनवर्ड्स टू लेट्स से रिएक्टिव इंटरमीडिएट्स. इसके बाद में हम स्टार्ट करेंगे लेट्स से नेम रिएक्शंस एंड organic reagents, for example, for the previous CSI net question. ठीक है. Also, hi Mohit and Yuvraj, everyone welcome guys. और जो लोग पूछ रहे हैं गेट के लिए अगर हम प्रैक्टिस करेंगे क्या, देखो गेट का इतने सारे अच्छे अच्छे क्वेश्चंस है गेट के. आई थॉट आई वुड मिक्स सम ऑफ द क्वेश्चंस इन फॉर CSI net प्रैक्टिस ऑल्सो. बट जैसे ही ये वाले क्वेश्चंस हो जाते हैं हमारे CSR नेट के, वी विल स्टार्ट द क्वेश्चन प्रैक्टिस फॉर गेट आल्सो. ओके, सो या फर्स्ट ऑफ ऑल वी विल डू क्वेश्चन प्रैक्टिस फॉर CSR नेट क्वेश्चंस एंड देन फॉर गेट, जिससे कि एक सेपरेट मतलब एक लाइव सेशन आपको पता चल जाएगा कि ठीक है ये गेट के हैं, तो आप आराम से प्रैक्टिस कर पाओगे. ओके, चलो फर्स्ट क्वेश्चन फॉर टुडे. मेजर प्रोडक्ट फॉर्म्ड इन द फॉलोइंग रिएक्शन. सो देखो पहला क्वेश्चन बहुत इजी है आज का, एंड इट्स अ एवर रिपीटेड क्वेश्चन. ओके, सो इफ यू वांट यू कैन जस्ट आंसर दिस इन 1 minute. Yes, right. First question. All right. एंड ऑल्सो गाइज अभी सबको पता चल ही गया है, CSI नेट ने नोटिफिकेशन दे दिया है, एप्लीकेशन स्टार्ट हो चुके हैं. फॉर्म फिल आउट कर दीजिए जितना जल्दी हो सके उतना जल्दी. ओके, एज सून एज पॉसिबल. लास्ट मिनट पे रश नहीं हो इसीलिए. Yeah, very simple question. Birch reduction followed by alkylation. Very repeated question also. तो ये देखो, when we are doing Birch reduction of this kind of substituted benzoic acid, ये तो substituted benzoic acid है. Where are the electron going to transfer? Electron किधर transfer होगा? Electron transfer होगा ऐसे, such that the electron density falls into this carbonyl, isn't it? The methyl is not going to be touched. एक radical इधर, ये एक और डबल बॉन्ड, ये एक डबल बॉन्ड और एक डबल बॉन्ड ऐसे. Right. This electron density is going to stay while this sodium is going to transfer one more electron over here, followed by अमोनिया गिविंग इट वन मोर प्रोटॉन। तो अगर ये रिडक्शन होता है तो रिडक्शन करने के बाद में it is going to give you something like this. See, the acid is going to become a salt because the medium is basic. अब कोई भी electrophile आ जाए, whichever electrophile you gave over here is going to be attaching over here on this carbon having the carboxylic acid. So the electrophile, which is our electrophile like this, Br CH2 CH2 CH. So this whole group is going to be added over here. That's it. Followed by hydrolysis, you get the carboxylic acid from the acid salt. ठीक है? Yes, Soumya, Unacademy पे class नहीं हो रही है. Actually, I have discontinued from Unacademy, Soumya. I have announced long ago. But yes, जो पहले की मेरी classes है वो existing है. जो plus students है who have already subscribed with my code, they are able to watch all the content. But new classes I am not planning on Unacademy. Okay. So yeah, let's continue over here only. Next, major product formed in the following reaction. ये भी बहुत easy है. Okay, this is also very easy question. See, here we have started from GOC. तो GOC से लेकर जितना भी organic chemistry का important topic है, all of those topics we are going to practice CSI net previous year questions on in this particular series. And then we are going to start, let's say, gate questions, or let's say we start inorganic chemistry. Let's see how it works. Good evening, Atharva. कंप्लीट कोर्स कहाँ पढ़ाएंगे नेक्स्ट गेट के लिए? देखते हैं सौम्या कहाँ पढ़ाएंगे, बट अनअकैडमी पे नहीं. ओके, यस, ऑल राइट. All right. Yes, guys. Very good. Very good. Very nicely answered again. So, phenanthrene molecule है, Birch reduction has to happen in the presence of a buffer. Buffer मतलब कि excess of reduction is not going to take place. ये buffer present है ना यहाँ पे, तो मतलब इस तरीके से reduction नहीं होगा, ना ही इस तरीके से reduction होगा. So 3 and 4 are both wrong. Only one double bond is reduced. So it is not possible to reduce like this. One is absolutely absurd. Why? Because phenanthrene ऐसे react ही नहीं करता है. This double bond, the 9-10 position, this is going to reduce because it is not affecting the aromaticity of the other two rings. So absolutely 2 is the correct answer. बहुत easy questions है. चलो अब ये वाला क्वेश्चन थोड़ा ट्रिकी है, बट अगेन इट इज वेरी इजी. सी, मेजर प्रोडक्ट फॉर्म्ड. व्हाट डू यू हैव? NBS, सिल्वर एसिटेट, DMF. इसे अथर्वा इसे बोलते हैं एनिलेशन इफेक्ट. That because the aromaticity is divided into the two separate rings, the central ring gets very less electron density. Only the middle ring will react. Annulation effect. All right. This one is an awesome question. क्योंकि क्या होता है when we are doing a reaction, okay, it's not necessary कि हमेशा एक ही set of reagents से एक reaction हो सकता है. We can use different set of reagents to carry out the same reaction. Okay, this is an example of such a question. Okay, let's see who will be able to answer. Okay guys, do you want a hint? हिंट चाहिए किसी को? फोर्थ वन मोहित, ऐसा लग रहा है जैसे आयोडोलैक्टोनाइजेशन है पर नहीं है. Prevost? No. Okay guys, try out wolf rearrangement. Is it possible? Wolf rearrangement possible है क्या यहाँ पे? Yes. What is wolf rearrangement? How does it go through? Yes, Hoffman bromamide. Okay, you can call that as well. क्योंकि युवराज, it is showing you a similar mechanism, but what is the important step? Right, you have silver acetate. What can that do? It can remove a proton from the nitrogen, but not just like that. NBS क्या करता है? NBS is going to provide you a bromonium ion. So let's say this nitrogen being more nucleophilic than oxygen is going to attack over the bromonium ion. And let's say we are going to have this molecule CO. This becomes NHBr like this. Okay, why NHBr? Because it is going to attack on the bromine और proton extra है जिसको ये acetate ले लेगा, so it is going to become NHBr. Now there is one more acetate. What is that going to do? This proton is even more acidic than the previous proton. Acetate ने proton ले लिया, Br minus निकल गया. What are you getting? You are going to get something like this. What is it? Nitrine type intermediate. Rest of the molecule is as it is. Nitrine है तो ये क्या करेगा? It is going to form isocyanate. Yes or no? Guys, Wolf rearrangement बोलो या Hoffman bromamide rearrangement या degradation बोलो. It is going to give you rearrangement and isocyanate. देखो यहीं पे connected था below the plane से. So this carbon has to it has migrated over this nitrogen C double bond O like this. ठीक है? Now, who is attacking over this carbon? Somebody has to attack over this carbon, either this oxygen or this oxygen. So according to the options, what is there? Because कोई external nucleophile तो है नहीं. DMF is not attacking, it's just a polar solvent. So the alcohols are going to attack. Which one? Option number 1 में this alcohol has attacked over this carbon, giving you a 5-membered ring. So 1, 2, 3, 4, 5. उसके लिए हमें bond rotation करना पड़ेगा, right? If we do the bond rotation, then only it is possible. So this alcohol can come, this bond can rotate, and we can have this one back. So this becomes NH, C double bond O, and ये O कहाँ से आया है? Alcohol से आया है. This has come from this alcohol. And the rest of the alcohol is as it is, CH2, CH2OH, as it is. Okay, one possibility. The other possibility is that this OH will attack. So 1, 2, 3, 4, 5 and 6. It will give you a 6-membered ring. Always remember, whenever there is a cyclization possibility, a 5-membered ring will do a cyclization much faster than a 6-membered ring. Why? Is it more stable? No. A 5-membered ring is formed kinetically faster than a 6-membered ring. So option number 2 is wrong. 6-membered ring नहीं बनेगा, 5-membered ring बनेगा. 3 is wrong, 4 is absolutely wrong again. Got it? तो basically हो क्या रहा है? Rearrangement reaction हो रहा है with a different reagent. How easy is this? कितना अच्छा question है ये? Yes, yes Nagesh, absolutely. You can call it that. Okay, या फिर एक काम करते हैं, जितने भी रिएक्शन है जिसमें आइसोसाइनेट बनता है. Okay, what if you recall, what are the reactions which form this isocyanate intermediate? Curtius rearrangement, Lawson rearrangement, Schmid rearrangement, Hoffman bromide degradation, all of them have the same mechanism. They are all going through the isocyanate. Okay, so it's okay. Whatever reagent is given over here, you just need to be able to identify. Okay. एग्जैक्टली युवराज, जल्दी तो हमें करना ही है, लेकिन हम जब इतने पास होते हैं करेक्ट करने के तो थोड़ा और ध्यान देना है, तब सही हो जाएगा. ये देखो एक और क्वेश्चन में एनबीएस. ठीक है, सो बेसिकली गाइस ऐसा नहीं है कि हम सिर्फ रेडिकल और कार्बीन कर रहे हैं. दिस सेशन इज मोस्टली अबाउट रिएक्टिव इंटरमीडिएट्स व्हिच इंक्लूड्स एवरीथिंग, कार्बोकैटायन, एनायन, इंटरमीडिएट लाइक आइसोसाइनेट, लाइक नाइट्रीन, लाइक एवरीथिंग. ओके, सबको इंपॉर्टेंस मिल रही है. Major product A and B formed in the following reaction sequence. Okay, there is no timer, so you can just relax and do this question. The only thing which is important is you must try and do it, do your best, do it correctly. ठीक है, कोई टाइमर नहीं है, कोई पोल नहीं है इधर. Yes Anisha, think again. Almost correct you are, but think again, because the products are almost similar, right? They're only asking you stereo. All right. Okay. Yes, Vanita, first part of your answer is correct. What about the next part? Yes, see, Navneeta, in the previous question, you considered some reaction. You considered it here. All right. Absolutely correct, Prasad. Absolutely correct. I was just waiting for one correct answer. Yes, Prasad. It is 4. Guys, ये आंसर है इसका. कैसे है? चलो करो, खुद से ट्राई करो. Why is it 4? Try this out once. Obviously, we are going to discuss. Why is it 4? See, we have some cyclopropane ring which is present above the plane, and this portion is planar. So how is the stereochemistry affected? हमने starting में वो dynamic stereo वाला session किया था, ठीक है? So from there also we understand that if there is any electrophile which has to add, let's say Br positive is given by NBS, so that Br positive is going to form a bromonium ion below the plane. This is for sure. This everyone understood. कि bromonium ion below the plane बनने वाला है. Everyone got that nicely. Now the question is that some acid is present. So if the 3-membered ring has to open, कहाँ से open करेगा वो? वो इधर से attack करेगा या फिर यहाँ से attack करेगा? That is the question. Regioselective ring opening. From where? See, this has become a loose SN2 reaction. Why? Because bromonium ion, whenever there is a nucleophile, whenever you are going through acid mechanism, it will give you mostly that stable carbocation. तो ये जो Br positive है, it is going to mostly stay like this. I am not saying it is forming a complete carbocation, but I am saying it is going to be loosely bound in this way. Got it? That means कि इस वाले पे इसका इंटरैक्शन कम है बिकॉज ये ऑलरेडी एक स्टेबल कार्बोकेटाइन बना सकता है. दैट्स व्हाई. So if the nucleophile is protonated and it has to attack, it is going to attack from the backside on this carbon. This is going to be a loose SN2 mechanism. So the nucleophile has attacked from above now, and the Br minus is below, and this is your above cyclopropane ring. So you have to see that the Br minus has to be below, the nucleophile is above. They have to be trans, isn't it? And also it is attaching, the nucleophile is attaching on the more substituted carbon. ठीक है? Yes. Diaxial also, if you see, this is a 6-membered ring. But you know, again, you have formed the bromonium ion below the plane in this way, right? And there is this cyclopropane which is above. All right. So now you see, ये वाला जो methyl है ये कहाँ पे होगा? ये already below the plane है bromine. So if the methyl has to exist, it is going to exist like mostly on the equatorial position. Diaxial attack. Yes. So nucleophile जो भी है ये इधर से attack करता है अगर, तब इसको ब्रोमीन यहाँ मिलेगा, and the nucleophile is here, the methyl goes equatorial. So see, cyclopropane ring is above. You are getting the diaxial attack. That's why this is going to be above, Br minus is going to be below. यहाँ से attack possible नहीं है. Okay, so ultimately we can do the same thing. We can follow the diaxial attack thing, and we can also follow this simple thing कि acid mechanism है. ठीक है, both ways we are going to get this. Be very careful about the stereo. Now once you have got this, फिर से हम इसको बनाएंगे cyclopropane above. Here was your Br और ये इधर है. अब ये क्या कर सकता है? This is a carbonyl. All right, ये तो carboxylate है, CHPH2 करके. What is it going to do? It is going to do NGP. Yes or no? Now this is like a Woodward dihydroxylation. इसने कर दिया NGP. Okay. If it is doing NGP from the above, the Br minus is going to go. Alright. Now what? ठीक है. After that, finally, aqueous workup, or let's say the tertiary butoxide base is going to remove this carbonyl from here. After the aqueous workup, you are finally going to get the same stereochemistry. OH above, OH above, ऐसे ही hydrolysis होगा इसका. Alright, so your answer is this. You're not getting trans. You're getting this thing. This part is correct in 1. लेकिन ये यहाँ पे कैसे आएगा? अगर 1 को follow करेंगे guys, then the diol should form below, isn't it? Because the carboxylate is below. So the diol should form below. ऊपर कैसे आएगा? So that is why in 1 the options are contradictory. So 4th is the correct answer. Okay? Got it? Let's move onwards. फिर से एक NBS का क्वेश्चन. चलो. Major product A and B in the following reaction sequence. Okay. Yeah, another easy question. Try it out. Yes, Yuvraj. See, careful this time. Everyone has to be careful. Alright guys, what are your answers? ये इतना मुश्किल क्वेश्चन नहीं है. Okay, only one answer which is correct. Rajdeep has given the correct answer, guys. What about your answers? What is happening over here? One double bond reacting with another double bond. How is it possible? ये कैसे हो रहा है? How to write this? अच्छा, first of all, you have NBS for example. तो जब भी NBS, आपको पता ही NBS is going to give you a bromonium ion if there is no radical initiator or heat or light, तो आपको पता है bromonium ion देगा, which means it is going to form something like this first of all. But you know that there is ethoxy, there is this oxygen, तो oxygen तो bromonium ion बनने नहीं देता है. What does the oxygen do? It will rather push it away and form the oxonium ion like this, isn't it? And who is going to take the benefit of that? This allylic alcohol. ये तो इसका फायदा उठाएगा, ये इसके ऊपर अटैक करेगा. It is possible, isn't it? The upper portion I'm writing like this, and the oxygen has attacked over this carbon. So it is having one ethoxy and one CH2Br. This. इसको हमने ऐसे लिख दिया. Okay, we have written it like this. Now in the last option, option number 3 and 4, why are they wrong? ये गलत क्यों है guys? सरासर गलत है. क्यों गलत है? क्योंकि कभी भी ऑक्सीजन ये Br यहाँ नहीं आ सकता है. Br cannot come on this carbon because this oxygen, this is trying to push it away. Yes or no? That's why this reduced selectivity of Br is wrong. Okay, चलो आगे बढ़ते हैं. All right, now let's move onwards. That it's very simple. After this, what can you see? You see TBTH AIB, and that is radical initiator. तो वो क्या करेगा? It is first going to give you this combination is going to give you a tributyl tin radical. Tin radical क्या करने वाला? It is going to abstract the bromine out of here. And then the reaction is very simple, cyclization. पर ये simple reaction ही confuse करता है. Which cyclization guys? Endo या फिर exo radical? क्या बनेगा? ये देखो. You are always going to, in the radical mechanism, you are always going to form exo radical. This is the carbon having the radical and ये carbon से connect हो गया. This is CH2 radical outside. Okay, so your answer is going to be option number 1. Why? Because of the exo trig radical being more favored. कौन सा rule follow हो रहा है? Baldwin's rule. Baldwin's rule of radical cyclization. Exo. Yes, very good. Very good, all of you. So this radical is going to take away one more hydrogen from here. तो आपका आंसर हो जाएगा 1. बहुत easy question था, कुछ भी नहीं था इसमें. Yes, still took you so long to answer guys. कभी कभी ऐसा होता है कि easy question में time लग जाता है. That happened. Yes राजदीप, मुझे conceptual question बहुत अच्छे लगते हैं. ये सारे CSI नेट के PYQ है, but these are some really awesome question. और मैं यही कोशिश करती हूँ कि मैं इनको topic wise लेकर आऊँ ताकि आप correlate कर सके. अभी ये सब अलग अलग साल के question है ना, लेकिन टॉपिक हमारा सेम है इंटरमीडिएट, इसलिए क्या एक फ्लो बन गया प्रैक्टिस करने का. और अगर यही क्वेश्चन आप ऐसे स्कैटर्ड देखते हो एग्जाम में, कभी रिएजेंट का आ रहा है, कभी रिएक्शन मैकेनिज्म का आ रहा है, कभी इंटरमीडिएट का आ रहा है, तो थोड़ा सा मुश्किल होता है सॉल्व करना. ठीक है, दैट्स व्हाई वी आर डूइंग इट टॉपिक वाइज. ऑल राइट, लेट्स मूव ऑनवर्ड्स. अब ये तो बहुत ही इजी है. The correct sequence of reagents to affect the following transformation. See, it's a reagents question, but you know, ultimately it's going to go through intermediates. बहुत easy है ये. Try करो. All right, guys. So, what do you think? Have we done this before? एक डबल बॉन्ड मिसिंग है यहाँ पे. ये एक डबल बॉन्ड मिसिंग है. आई पुट इट ओवर हियर. नाउ कंसिडर. Absolutely. Absolutely. D is the correct answer. Very good. What is happening over here? जिनको पता है, जिन्होंने पहले किया है, उनके लिए बहुत इजी है. जिनको नहीं पता है, for those who are looking at this question first time, have we discussed this molecule in aromaticity? Yes or no? Aromaticity में हमने देखा है ना that this CH2 is going to have a proton NMR spectrum of let's say -1.4 या -1.0 something. Yes or no? What kind of a compound is this? This is a 10 annuline system, okay, which is held by a CH2 bridge, methylene bridge, right? तो ये basically 10 annuline जैसा ही है, लेकिन बीच में एक bridge आ गया. So this has now become a homoaromatic compound. Yes, it has become a homoaromatic compound. All right, very well. तो अब इसका जो synthesis है वो देख लेते हैं. Naphthalene से बहुत easy है. Naphthalene molecule I'm writing over here. Okay, let's write it like this. Now in the first reagent in option number D, what are we doing? We are doing Birch reduction in ethanol. कोई बफर नहीं है, इसका मतलब दोनों रिंग रिड्यूस हो सकते हैं. दोनों रिंग कैसे रिड्यूस होंगे? 1,4 रिडक्शन over here. And same over here, that electron reduces both of the rings such that I'm writing the final product, okay? Not writing the mechanism of Birch reduction. I'm doing 1,4 reduction. So these two carbon got dihydro. तो 3 डबल बॉन्ड आ गए यहाँ पे. सेकेंड रिएजेंट में आया CHCl3NaOH. What is this reagent doing? ये तो कार्बीन बना रहा है. Which carbene? Dichlorocarbene. Like this. A carbene is electron deficient neutral species. It is going to be attacked. Cyclopropanation हो जाएगा, but कहाँ से होगा? The central most electron rich. Most electron rich. तो कर देते cyclopropanation. So let's say we write it like this. All right. And the double bond here. थर्ड में फिर से रिडक्शन हो रहा है. बर्च रिडक्शन जैसा लग रहा है, बट ये बर्च रिडक्शन तो नहीं है. It is not Birch reduction, but it is dehalogenation. That is, these two chlorines are being removed, okay, and it has taken a proton. ये कैसे हुआ? From the same reagent, how is this happening? This electron is falling over this carbon and this Cl minus is taking away the electron density. And it is forming Na plus and Cl minus like this. Okay? Yes. Heteroatom cleavage. Exactly, Dipanshu. ये हो गया हमारा dehalogenation. You got it. Now the last step, DDQ. This is the most important step. How does it proceed? कैसे करेगा DDQ oxidation? ये देखो, DDQ को क्या चाहिए? DDQ needs 1 proton and 1 hydride. Okay, so 1 proton gone from here और एक ये पूरा H चला गया इलेक्ट्रॉन डेंसिटी के साथ. This has gone to DDQ. H plus and H minus. Now the molecule is rather looking like this. ऐसा दिख रहा है ये molecule after DDQ oxidation. One more is required. One more H plus and H minus has to go. फिर क्या होगा? रिंग खुल जाएगी. कैसे खुलेगी? ये देखो, ये बीच वाला बॉन्ड है, ये खुलेगा यहाँ से, एंड दिस H minus is going to go like this. ठीक है? Now you are going to get this product from here. What is DDQ? It is dichlorodicyanoquinone. Look at the structure of DDQ. इसको क्या चाहिए है? इसे एक तो हाइड्राइड चाहिए H minus. H minus आ गया यहाँ पे, and then after cyclization it needs a proton such that it becomes reduced. Hydroquinone it becomes now. और ये बन गया है अंदर से बेंजीन. ठीक है? So DDQ is going to take electron as such. Okay? So aromatization. Very nice. Very nice question. This is option number D. It has been asked twice in your CSI net exam. गेट में भी आएगा, बिल्कुल आएगा. चलो नेक्स्ट. वेरी गुड क्वेश्चन. Intermediate involved in the given transformation are. Yes, Dipanshu, that gives great confidence. पहला क्वेश्चन ही राइट हो जाए तो. And sometimes, you know, in the exam, guys, when you have practiced so many questions, तो आपको एग्जाम में देख के पता चल जाता है कि मेरे को पता है कि ये क्वेश्चन सही होने वाला है. Okay, because I have done it from a nice source. So I know it will be correct. That has happened with you in the exam. कोई भी क्वेश्चन के लिए. That you know it is going to be correct. Yeah, that does not happen very often because common questions don't appear very often, but one or two questions you can get that feeling. Yes, all right. Yes, very easy question. Very, very easy question. Dipanshu, Disha, Navneeta, Ashika, everyone. Correct. Very nice. So intermediate involved बहुत easy है. ये OH minus क्या करेगा? OH minus is going to take away a proton from here. That is going to give you A, and A is going to attack back on such a molecule. ये फिर से अब इसके ऊपर अटैक कर देगा. That's going to give you B. Now B has to undergo E1CB elimination to give you this molecule. How easy. So A and B are correct. C और D नहीं बन सकते ना, क्योंकि अब ये O minus बन चुका है. O minus is not going to give you the double bond. OH is not a good leaving group. Yes. Chalo. Next one. All right, that's great, Navneeta. It's really good. नाइन्थ क्लाउड पे चले जाते हैं. यस, डेफिनेटली. ऑर्गेनिक का क्वेश्चन वो भी करेक्ट हो जाए तो ऐसा ही लगता है. ये बहुत इजी क्वेश्चन है. दिस वन इज सुपर इजी एंड सुपर रिपीटेड. Yeah, sometimes we should also take easy questions for boosting confidence. Yes, very good. All of you. 3 is the correct answer. How do we know? It's very simple. In the presence of this trifluoroacetic acid, what happens is this carbon-nitrogen bond is going to break down. It is going to give you a carbene. What are the different possibilities of a carbene? Many possibilities. Sorry, there is no CH2 over here, so sorry. तो एक कार्बीन क्या कर सकता है? After the carbene it forms, let's say there is going to be a CH like this. Yes, a carbene could do Wolff rearrangement. All right, ये कर सकता है. Acyl carbene है, it can do a Wolff rearrangement, but it does not. It is going to be rather attacked from the para position of this ring. Why is that so? ऐसा क्यों हुआ? क्योंकि न्यूक्लियोफाइल अवेलेबल है, इंट्रामोलिकुलर न्यूक्लियोफाइल इज अवेलेबल. एंड लेट्स से आई एम मॉडिफाइंग दिस क्वेश्चन. मैंने अगर आपको ये मिथाइल वाला जो मिथॉक्सी ग्रुप है, आई हैव नॉट गिवन यू दिस ग्रुप ओवर हियर. लेट्स से आई हैव पुट इट ओवर हियर, or let's say I've put it over here, then what will happen? Then again it is going to follow the ortho-para attack. See, as long as there is a possibility, the attack is definitely going to happen. Okay, ये एक minus charge आ गया है यहाँ पे. There is a positive on the oxygen. Now what will happen? It is going to take one more proton from the acid which is present. Okay, और ये जो methyl group है ये यहाँ से निकल जाएगा because water is now going to attack over the methyl. So this bond breaks. You're going to get one carbonyl over here, and this CH minus took a proton to become CH2. This is your answer, not this. Why? Because the methoxy is going to attack from its para position, not from the meta. यहाँ से ये meta पे आ गया है, ठीक है? So that's it. Very easy. The other two options are wrong because there is no CH insertion taking place. No. चलो आगे चलते हैं. ये तो हमारा करा हुआ क्वेश्चन है. आगे ये देखो. The reaction that gives E2-methyl hex 3-ene as the major product is. Yes, the previous question was an example directly taken from Caruthers. Yes, Shubhadeep. You appeared in the beginning and then you're saying you're late. All right, let's see this question. Very good, yes. देखो PYQ तो repeated हो गए ना. PYQs when you are solving, then it gives you this confidence कि okay, I've seen this question, maybe a similar question will appear. So ये तो रट गया है question. अब इसके जैसा कुछ आएगा तो कर लेंगे. Okay, all right. No issues. Shubhadeep, try all those questions out which you have missed. Yes, ये भी PYQ है. What is happening in the first reaction? First one, Peterson Olefination. Okay, absolutely Peterson. Which medium? Acid के presence में हो रहा है, तो acid के presence में it is going to be anti. लेकिन see, you have already arranged them in the syn group. They are basically like this. अब इसको anti बनाने के लिए we have to rotate the molecule. Let's say if I rotate from here, then only it is going to become anti. Okay. अब ये anti हो गया है, right? Let's say there is an F minus which is attacking. So if see the question is, what is the dynamic stereochemistry? This OH and the SiMe3, they are already placed in the anti position. ये same side पे नहीं है, ये दिख रहा है same side पे, but the molecule is trans. Okay, because it is in the written in the zigzag format. When you write it in the same side, then it is going to become trans. So to a trans molecule, when you are doing anti-elimination, what is going to happen? You are going to get a cis alkene, yes or no? The groups are already trans. उसके ऊपर भी एंटी एलिमिनेशन कर रहे हैं तो सिस एल्कीन मिलेगा ना, ट्रांस कहाँ से मिलेगा? ओके, दैट वन ओनली यू कैन अंडरस्टैंड. यहीं से समझ में आ गया कि सिस मिलेगा. यू आर नॉट गेटिंग अ ई एल्कीन. Next is in the presence of heat, you are going to have E1 elimination. In the presence of heat, it is going to give you this kind of a double bond. तो क्या ये इसमें क्लासिफाई करता है? You cannot find out a E and Z for this. Okay, तो ये गलत है ये आंसर. Next one, ये तो Wittig reaction हो गया because there is a ylide. Is it a stable ylide? No. Unstable ylide will again give you Z alkene. Somewhat like this. ये bond तो फिर से Z alkene बन गया है. So again wrong. Last one is a Julia olefination. वो भी Julia Kochinsky olefination है ये. Isn't it? एक होता है Julia Litho olefination where you are doing the reaction in 2 steps. Julia Kochinsky you do the reaction in 1 step only. You see this tetrazole ring? इसको देख के समझ में आ जाएगा. It is Julia Kochinsky. It is a 1 step reaction. 1 pot synthesis. So it is going to absolutely going to give you the E alkene without any doubt. This part is going to connect over here and it's going to give you E alkene. The structure is going to be like this. अच्छा, एक कार्बन एक्स्ट्रा लिख दिया मैंने इसके अंदर क्योंकि एक तो ये कनेक्ट हो गया एल्कीन से एंड द सेकेंड वन इज गोइंग टू बी दिस. ऑल राइट, this part is not there. So this is the alkene. Okay, yes, so it is Julia olefination and the answer is option number 4, the one that gives you this alkene. All right, not so difficult. चले आगे. ये देखो, मैंने अभी अभी थोड़े दिन पहले रिमाइंड कराया था आपको कि बहुत ही इंपॉर्टेंट रिएक्शन है. ऑन इंस्टाग्राम आई टोल्ड यू the example. Major product formed in the following reaction. Which reaction is this? Let's say if you can identify. बहुत easy है. Absolutely guys, Claydon solution manual is a gem and there are many questions in previous years which have directly appeared from the solution manual. So you must not miss it out. But be time specific. Sakurai Allylation. Yes. Lewis acid mediated nucleophilic attack on the carbonyl. Sometimes it's a direct attack, sometimes it's a Michael addition. Yes. All right, very important. Yes, it is. Acha, try karo mechanism. What is going to be the answer? All right. Yes, guys. All right. So this is our second last question. We have one more question to be done. ठीक है. चलो आंसर करो जल्दी से. Yes. Very good, all of you. Very good. Major product formed in the following reaction. Again, see, acid mediated. So this is going to react with TiCl4. ये bond बना लेगा अगर, if it forms a bond with TiCl4, then one of the Cl minus has to be lost, right? And let's say isopropyl silyl group को हम लिख देते हैं SiR3. Okay, like this. Okay. Now what happens? This oxygen has a positive charge, तो ये इधर से resonance ले सकता है, right? And this pi bond is going to attack over here. OTiCl3 बन गया है, and there's a new bond formation. This is a new bond formation between the allylic system. Okay. अब ये जो SiR3 है गाइस, इसके पास वाले कार्बन पे, ठीक है, अल्फा एंड बीटा कार्बन के ऊपर पॉजिटिव चार्ज है, like this. What is going to happen? That free Cl minus is going to attack over silicon and the bond falls up over here. ठीक है? So this is going to become a double bond in this way. ये बन गया डबल बॉन्ड यहाँ पे. All right, another double bond like this. What is going to happen next? Next, you know that there is this TiCl3 has to remove somehow, right? तो इसको अगर remove होना है, so what is it going to do with the electron density? It is going to make this carbonyl from here attack over this carbon. And if such a thing happens, how many membered ring will form? यहाँ से count करो. 1, 2, 3, 4, 5. A 5-membered ring is going to form, which will have the carbonyl over here on the junction, because this is not reacting. This junction carbon is reacting and has formed a 5-membered ring. Where is the negative charge? Negative charge कहाँ पे है? ये कार्बन है, इस कार्बन ने यहाँ पे अगर अटैक किया है, so 1, 2, 3, 4, 5 ring it is forming, and the negative charge is over here, like this. ठीक है, क्योंकि ये वाला कार्बन आ गया, this is attached over here, the negative charge goes on to this middle carbon. Now what is going to be the fate of the negative charge? Yes, और कोई इलेक्ट्रोफाइल तो है नहीं हमारे पास, so it is going to attack over silicon and Cl minus is set free. So your answer is option number 1. It is Sakurai Allylation reaction, but usually you have some hydrolysis or let's say aqueous workup at the end. If you had aqueous workup, यहाँ पे सिर्फ एक प्रोटॉन आ जाता, लेकिन aqueous workup नहीं है. That's why the silicon electrophile attaches back to this carbon. That is the only difference. So answer is option number 1. How easy? Very nice question this one. चलो last question for today. आज हमने शायद 10 questions कर लिए हैं. Major product A and the byproduct B formed in the following reaction. A is the major product and B is the byproduct. It is mentioned in the question. Also guys, again reminding you all कि आपका CSI net का जो application form है, that has already started. If you have not already filled out the form, please do at the earliest for those who want to give the exam. और आपको कोई भी query है regarding the application form, you can post in the comment section of whichever video, because I'll be able to see. So कोई भी question हो आप मुझे पूछ सकते हैं. Core-winter olefination. Yes, it is a name reaction. But what is the intermediate formed in between? Yes. बहुत अच्छी बात है कि आपको नेम रिएक्शन भी आता है, ये वाला बहुत ही अच्छी बात है. All right. Chalo. So A is the correct answer. Name of this reaction is Corey-Winter Olefination. But do we have an intermediate? I think we do. तो ये देखो, ये वैसे तो ट्रांस ये दिख रहा है कि ये सिस डायोल है, बट ये सिस नहीं है. इट इज नॉट सिस बिकॉज द चेन is zigzag. So whenever you are doing olefination from here, Corey-Winter olefination is a syn elimination reaction. Yes or no? तो अगर आप ट्रांस डायोल ले रहे हो, दिस इज अ ट्रांस डायोल. ट्रांस डायोल पे सिन एलिमिनेशन विल गिव यू ट्रांस अल्कीन. ट्रांस डायोल पे एंटी एलिमिनेशन, जैसे हमने पीटरसन किया था, पीटरसन वाज एंटी, हियर इट इज सिन, so it's going to give you trans alkene. ट्रांस डायोल के ऊपर अगर हम सिन एलिमिनेशन कराते हैं, we will get trans alkene only. So we are not getting 3 or 4, we are getting 1 or 2, but that also depends on what is our byproduct. तो सबसे पहले क्या होगा, the oxygen over here, see the whole thing is, ये आपको जो बड़े बड़े ग्रुप दिख रहे हैं, these are nothing but good leaving groups, so they're just going to get eliminated when the diol is going to attack. So you are actually having C double bond S like this. This is a 5-membered ring. Okay, ये ऐसे trans में है, but it is a 5-membered ring which has formed. Now in the next step there is phosphite. ये इसका क्या काम है guys? इसका काम है सल्फर पे अटैक करना. ये बॉन्ड ऐसे खुल जाएगा, ये बॉन्ड यहाँ चला जाएगा फॉस्फोरस पे बैक अगेन. What are you going to get? You are going to get a carbene intermediate. ये देखो इस तरीके से यहाँ बन गया कार्बीन. So this carbene is neutral, this carbon is neutral. अब अगर ये न्यूट्रल है तो ये क्या करना चाहेगा, इट विल टेक इलेक्ट्रॉन डेंसिटी फ्रॉम दिस ऑक्सीजन, दिस कार्बन ऑक्सीजन बॉन्ड. ओके, एंड द अदर कार्बन ऑक्सीजन बॉन्ड, ओके, इट्स गोइंग टू गिव द इलेक्ट्रॉन डेंसिटी. सो दिस अदर बॉन्ड इज गोइंग टू फॉल लाइक दिस, और ये बॉन्ड यहाँ फॉल करेगा. एलिमिनेशन ऑफ CO2 मॉलिक्यूल एज वेल एज द alkene you are going to get. तो CO2 मॉलिक्यूल निकलने वाला है एज वेल एज सल्फर एंड फॉस्फोरस बॉन्ड. दिस इज व्हाट यू गेट. ये जो सेकंड वाला ऑप्शन है ना, मेनी पीपल हैव आंसर्ड इनकरेक्टली ओवर हियर. बी केयरफुल, दिस इज व्हाट यू आर गेटिंग इन द xanthate एलिमिनेशन. आपको मिलता है xanthate pyrolysis में, चुगेव एलिमिनेशन में. दिस डज नॉट फॉर्म ओवर हियर. सल्फर एंड फॉस्फोरस बॉन्ड लीव्स. ओके, so absolutely first one is the correct answer. Syn elimination from a trans diol will give you a trans alkene, and these are the byproducts. Okay, so be careful about the byproducts. कभी कभार पूछ लेते हैं ये एग्जाम में, ठीक है, not always, but yeah, these are important. चलो, so guys, yes, our session ends for today. आज के लिए हम इतनी प्रैक्टिस कर चुके हैं. we will meet up again tomorrow. एंड कल के लिए हम थोड़ा सा और थोड़ा एडवांस जाते हैं गाइज. लेट्स प्रैक्टिस सम क्वेश्चंस ऑन ऑर्गेनिक रिएजेंट्स एंड नेम रिएक्शंस. ओके, बिकॉज ये जो टॉपिक है रिएजेंट्स का और नेम रिएक्शन का, दे कैन नॉट बी सेपरेटेड फ्रॉम ईच अदर, राइट? दे आर गोइंग टू बी आस्क्ड टुगेदर ओनली. So in the next session, that is tomorrow, we are going to discuss reagent and name reaction questions. And I'm going to take some recent year question just like this. जैसे मैंने अभी लिया है वैसे ही हम नए questions लेंगे जो recent exam में आ चुके हैं. Okay, so please revise reagents and name reactions. All right. So yes guys, I'm going to see you all soon. Reminding all of you, CSINet application form is out. Please fill out the forms. Okay. Organic spectroscopy will come eventually. Yes, दीपांशु में भी let's say अब यहाँ पे मैं सेशन क्रिएट करके रख सकती हूँ वैसे तो, बट पहले हम रिएजेंट नेम रिएक्शन करेंगे, उसके बाद 4-5 सेशन के बाद स्पेक्ट्रोस्कोपी का नंबर आएगा. बट या डेफिनेटली वी विल डू दैट. ओके, चलो, आई सी यू ऑल सून. बाय एवरीवन, टेक केयर. बाय बाय.